Hey everyone, Sean Watasa here, back with another video, and in this video we're going to go over how to build your very own dapp or Web3 application. We're going to go through some of thirdweb's toolings on how you can create your own contracts, deploy them, and even create a front end to start interacting with those contracts. We'll go over and cover some of the basics to help you start your Web3 development journey and show you how easy it is to build these Web3 applications using thirdweb. So an overview of what we'll be covering in this video: we'll first create our very own smart contract. We'll also deploy it. We'll then build our very own front-end application to interact with that smart contract. And at the very end, you'll have a simple counter dapp that you'll be able to interact with and even deploy. So with all of that being said, let's jump onto the computer here and start building out our contract first. So on my computer here, I have my terminal open, and the first thing we're going to do is create our contract. So I'm going to run npx thirdweb, and we're going to do create contract. And again, this is going to allow us to create our very own smart contract. So right here, we're just going to name our project. We're just going to name this simple counter contract. We're going to use Forge for this. We're going to name our smart contract. I'm going to name it simple counter. And we're going to use an empty contract. Now, if you are building a contract and you want to start with a base ERC 721 or ERC 20 or 1155 contract, you can actually select these contracts here and it'll set up a base contract for you. Or you can do what we're going to do and just create an empty contract, and we're going to build our smart contract from scratch. Once that's done, we'll just change into our simple counter contract. We'll open this up in our code editor. And once we have it open, we're going to go into our sources folder here, and we're going to open up our contract.so file. And this is just a Solidity file here for our smart contract. So let me just close that here. We're just going to rename our contract here to simple counter. And right over here, we can start creating our very own smart contract, and we'll also be able to deploy it as well. So again, for this tutorial, we're going to be building a simple counter application, which is going to have a number that we can increment or decrement, and we'll be able to retrieve the count. We'll also create some functions to like reset the counter and things like that. So for our smart contract here, we're just going to create a few variables. So our first one is going to be a uint 256. We'll make it a public variable here, and we're going to call it counter. And this is just going to be the counter that we're keeping track of. The second one is we're going to create an address, and we're going to make it public as well, and we're going to call that variable owner. So we're going to add a reset button, but we're going to make it so that only the owner of the contract, the person who deployed it, can reset the contract or the counter. No one else will be able to do that. So in our constructor function here, this constructor function is a function that gets called once at the time of the contract being deployed. We're going to set the counter here to 0. That's what our counter is going to start off at. And we're going to set the owner of the contract to the msg.sender. So whoever is deploying the contract is going to be set as the owner of this. Next, we're going to create, before we start creating our functions, we're going to create a modifier, and we're going to call this modifier only owner. And this modifier here is going to require that the sender of the transaction, or the person executing it, has to equal the owner. So has to equal the address of the person who deployed the contract. If not, we're going to say only the owner can call this function. And again, we're going to use this modifier on our reset function for resetting the counter. So the first function we're going to create is an increment function. This is going to be a public function. We're not going to make it only owner. It is going to be callable by anyone, and all it's going to do is increment the counter 1. So whatever the counter is at, we're just going to increment it once. The next function is going to be a decrement function. So same thing, public, it's going to decrement the counter 1 as well. But before that, we're going to require here. So we'll put a requirement, and we're going to say that the counter needs to be greater than 0. And basically, this will prevent us from going negative. So 0 will be the lowest that our counter can go to. If it is at 0, then we won't be able to decrement the counter anymore. Next, we're going to create that reset function. And that reset function, we're going to add our only owner modifier. So again, only the owner, the person who deployed the contract, can call this function. If the caller of the function is not the owner, then we won't be able to reset the counter. And this just sets the counter back to 0. And down here, we can get another function here, which is going to be called get counter. It's going to be a public. It's going to be a view function. So it's just for us to read the counter variable. And it's going to return to us a uint 256, which is what we made our counter right here. And that, again, it's just going to return our counter so we can get the number at which our counter is set to. Now, this is a very simple smart contract here that we're going to be using to create our very own dapp. And again, it's a basic counter smart contract where we can increment or decrement a counter here. And we have the ability to reset it, but only that function will only be callable by the owner or deployer of the contract. So now that we have a contract created, let's actually deploy this contract. Now, normally you would have to set up a bunch of things to deploy your smart contract, but with thirdweb, we make it very easy and you won't have to import any of your private keys or anything like that. We'll allow you to deploy this smart contract directly from the thirdweb dashboard. That way you'll be able to use an installed wallet in your browser, like a MetaMask or Coinbase wallet, to deploy your smart contract. Or if you choose to do so, you can sign in with an embedded wallet using their email or social login to the thirdweb dashboard, and you can even deploy from that wallet as well. So in order to do this, all we're going to do here is open up our terminal, and we're going to run npx thirdweb deploy. And when we run npx thirdweb deploy, you'll see that it'll detect our project type, which is Foundry. It'll compile our project. It'll upload our contract data to IPFS, and it will then open up a browser window, which will have a deployment window just like this. So you can see here, we're deploying our simple counter. We can then select the network or chain we want to deploy on. I'm going to be using Mumbai for this tutorial, but you can select this drop down here, and we support any EVM compatible blockchain. So you can search the chain that you're looking for here, and you can search through over 1,000 of these different chains and deploy to the one that you select. So once you have selected the chain or network you want to deploy on, you can just hit deploy now. We'll confirm that transaction to deploy our smart contract. And again, we're deploying this contract using our installed browser wallet. We'll sign this transaction here to add it to our thirdweb dashboard, where we'll be able to interact with our contract and also get some analytics on it as well. And again, this is a way you can deploy your smart contracts without having to worry about the security of using something like your private key or anything to deploy your contract. So once your contract has been deployed and we add it to a thirdweb dashboard, you'll get something that looks like this. You'll have the name of your contract. You'll have the network that it was deployed to. You'll have the contract address. Down here, you'll have some analytics. If there's some activity on top of your contract here, you'll see any of the latest events as well. Now, if we look here on the left-hand navigation, we can head to the Explorer tab here, and you can think of this as like an Etherscan if you're familiar with Etherscan. Basically here, you can look at the write and read functions of your smart contract. So in this case, our write functions here, we have a decrement, increment, and reset. Those are the three functions that we created on top of our counter smart contract. We can also look at the read functions here and read some of the data on our smart contract. So like our counter here, or using our get counter function, you can see that it returns 0 because we set the counter to 0 in our constructor function. We can even look at the owner here, which should be set to our wallet address of the wallet that deployed it, ending in B8 B2, which is this wallet that I have connected here, which is again the wallet that was used to deploy. Right above that in the left-hand navigation is code snippets. And you can see here we have some code snippets to start interacting with our smart contract. So right here, we can see how we can get an instance of our smart contract and how we can start calling some functions and everything from our smart contract as well. So now that we have our smart contract deployed, let's now build a front-end application where you can start interacting and creating a UI to interact with this smart contract. So coming back to my terminal here, I'm going to clear this out and I'm going to run npx thirdweb create app. And this time we're going to create an app. We're going to name this our counter app. And we're going to use Next.js and TypeScript for this application. Once that's done, we'll change into our counter app. And we'll open that up in our code editor as well. Once that's open, we're going to first head into our pages folder, and we're going to head to the _app.tsx file. And in this file here, you can see we have something called the thirdweb provider, which is going to wrap our application. And this thirdweb provider has a couple of things that we need to set up. One being the client ID, which is going to be something that we get from our API key. And the other one is the active chain. So we're going to set the active chain first. It's in this variable right up here. By default, it's going to be set to the Ethereum mainnet, but we're going to change it to the chain that we deployed our smart contract to. So in this case, we're going to change it to Mumbai because we had deployed this contract to the Mumbai blockchain earlier. Next, we're going to set the client ID. You can see we have it stored in an env file. And if we come on to the left of our files here, we have a .env.example, and this is where we'll have to provide our client ID. So coming back to our thirdweb dashboard here, I'm just going to open up settings here. And in our settings, you're going to create a new API key. So you can come up to the top right here, create a new API key, name it, and we'll just call this counter app. We'll just call this counter dapp here. And for this, we're going to keep everything on as is. You can toggle these services depending on what you need for this API key. For the restricted access here, I'm going to just add unrestricted access just for this. But in here, you can add in the allowed domains for this API key. We're going to hit create, and you can see we have our secret key here and our client ID. So you'll want to store this secret key here somewhere safe. If not, if you lose this secret key, you'll have to regenerate a new client ID or API key to get a new secret key. We're just going to copy our client ID here and come back to our application here and paste that into our environment variable file. I'm going to also rename this here, get rid of example, and just leave it at .env. So back in our _app.tsx file, we set up our client ID. We also set up our active chain. Next, I am going to go into my styles folder here, and I'm going to head to this home.module.css file, and I'm going to add a few styling here just for our application. Now, this is just to make the application that I'm going to be building out here look a bit nicer. And you can see here, I have just added a couple things like this counter container, button container, and app button. Just some styling, again, just to make the styling of this video look nice, but you can add in your own styling here if you need to. Okay, I'm going to close that. Next, I'm going to come back to my files here, and I'm going to create a new folder. We're going to call this folder here constants. And in that constants folder, I'm going to create a new file here called addresses.ts. And in here, we're going to export our a variable called, export a variable called contract address. And this is going to equal our contract address of our smart contract that we've deployed. So I have that contract address here. I'm going to paste that in. And that way we can use that throughout our app. So next, we'll head back to our files. In the pages folder, we're going to head over to the index.tsx file. And in here, you'll see some template code that is generated for us. We're just going to delete everything within this div that has the container styling. So I'm going to grab all of this here. Remove that. Remove this image import. And then in here, we're going to add a connect wallet button. So using connect wallet here, it'll add a connect wallet UI component to our application, which with this one component here, you now have the ability to connect wallets like MetaMask, Coinbase, Wallet Connect, and you'll have a nice pre-built connect wallet button for you to use within your application, and it's ready to go out of the box. And all you need to do again is just add this connect wallet UI component. So we'll just add a header here, and we'll just call this a counter app or dapp. So if I open up my terminal here and I run a yarn dev, we can take a look at our application so far. So right here, our app is open. We can see our header here, counter dapp, and this is the connect wallet UI component. So again, just with that one component here, you get a button for connect wallet. And when you click on it, you have all these wallet connect options here. This whole modal, including the button as well, is fully customizable from colors to branding. You can change even the icons and the metadata and title of these wallets here. And if you want to learn a little bit more about customizing these options, we do have another YouTube video going into how to do that. We'll drop that down in the description below if you want to check that out. But out of the box, again, you get this default button here with all these wallets you're able to connect. So we can just connect our MetaMask here, and you can see we have a nice connected modal or component as well when a wallet is connected to our application. It'll show the address, the balance, the wallet icon, and everything. And you can even do some other features within this connected modal, like send and receive tokens. We can switch accounts if we have something like a MetaMask wallet connected, and we can switch to our different accounts, or we can just disconnect our wallet right here. So again, all of that features and functionality you get with that Connect Wallet UI component, and you can check out more videos about it down in the description below. But we now have our Connect Wallet button, so we're able to connect a wallet to our dapp. We have our title here. Next thing we want to do is display our counter. So we're going to come back to our code editor here and drop this down. So in order to display our counter, we have to do a few things. The first thing we're going to have to do is get an instance of our contract so that we can actually read the data from our contract. So I'm going to create a variable here, and then we're going to get back a contract. And we're going to use a React hook called useContract. And this is going to get our instance of our contract here. We're just going to import that from thirdweb. And we have to provide it with our contract address. So again, we stored that in our addresses file. So we have our contract address there. We'll just give that here. And again, we now have an instance of our contract, and we can start reading and writing data to that smart contract. So we're actually going to read some data first, and we're going to create a variable. We're going to get back a data property here. We'll just call this counter. We can also get the loading state of it. So we'll say is loading, and we'll just say is counter loading. And then we're going to use the use contract read hook here. And what use contract read is going to allow us to do is call any read function from our contract. So if we look at our use contract read, let's import this real quick. If we look at our use contract read hook here, you can see right here we need to provide it one with our contract, and then we need to provide it with the function name. So our contract is going to be our contract that we got up here. And then we're going to provide it with the function name that we want to call. So in order to get our counter, we can even come back to our contract. And back in our contract, if we come to the Explore tab again and we go to the read functions, we can get the get or the counter by using the get counter function that we created. The name of the function is this right here in the parentheses. So we can copy that, come back here, and we can use the get counter function. And again, this hook here is going to read that function there on our contract. So once we get that information, we can now display that within our application. So I'm going to create a div here. We're going to give this div a class name just for some styling here. And this is going to be our counter container. And within this counter container, we're going to make sure that the data that we're reading from our contract has loaded. So if it is still loading, we'll keep the counter here at 0. We just give it some larger font size and some font weight of bold. And once we do have the counter, we will then display that. So we're going to get counter. Now counter is returned to us in a big number. So we're going to have to convert that number or that big number into a number that is readable. So we're going to use a 2 number here, and that should convert our big number into a number that we can display. We're just going to give this some of the same styles as well. So again, we are checking our read function here, we're checking is counter loading. So this lets us know if it is still loading the data from our read function right over here. Once we have that data, we stored it in counter, and we're going to display that number right over here. Again, we get it returned in a big number, so we're going to use toNumber to convert that to a number that we can display. So coming back to our app here, you can see we have a big number 0 because we haven't incremented or changed the counter in our smart contract yet. So next thing we're going to do is add some increment and decrement buttons here that will allow us to call the increment and decrement functions from our smart contract. Now, we only want to show these buttons if a wallet is connected to our dapp. Because they are functions on top of our smart contract, the only way to execute those functions is by using a wallet and paying the gas and transaction fee to execute that function. And we won't be able to do that if we don't have a wallet connected to our application. So we don't want to display those buttons unless we actually have a wallet connected. So to do that, we're going to use a hook called useAddress. So over here, I'm going to create a new variable called address, and we're going to use the useAddress hook here from thirdweb. And what useAddress is going to do is return us back a string of the connected wallet address. If there's no wallet address connected, it's going to return us back this undefined. So we can use that to actually display. We can actually use that to display our buttons if there is a wallet address connected, because if there isn't, we'll have an undefined and we won't display those buttons. So right below our counter here, we're going to make sure that we have an address, and only if we have an address will we display the buttons that we're going to create. So I'm going to create a div here. We're going to create a class name. We'll call this styles.button container. And within this button container, we're going to create our 2 buttons. Now we're going to use something called a web3 button, which is a UI component from thirdweb. And we're just going to put a minus button there. And then we'll copy this and we'll add a plus button here. Now, what this web3 button allows us to do is call and execute a function from our smart contract. So a web3 button requires a minimum of 2 things. We need the contract address that our button is going to interact with. So in this case, we'll give it our contract address that we stored in our addresses file. And then it needs to have an action. So for this specific button, because it is our minus or a decrement, we're going to get our contract. And what we can do on our contract, create an arrow function there. On our contract is call, and we can call any function from our contract. So in this case, we are going to call our decrement function, and we will provide it with any arguments if there is any arguments that need to be provided to this function. So if we take a look back at our contract, we can go to the right function here. We have decrement, and you can see the function name here. Now, this function does not have any arguments. It's just going to decrement our counter as long as it's greater than 0. So come back to our code editor here. We're going to do the same thing. So I'm going to copy this, paste it in, but this one is going to be our increment function. So now if we come back to our app here and we look at our app, we don't have the buttons, but that is because we don't have a wallet yet connected to our application. So if I hit connect wallet and we connect like our MetaMask wallet here, you can see we now have 2 buttons here, and decrement and increment button. And now we can actually click on these buttons to execute the increment and decrement functions within our application. So since we're at 0 here, let's hit decrement because we added that requirement that the counter must be greater than 0. You can see here, we didn't get any transaction or anything that went through. If we open our console here, you can see we got an error saying the reason saying our counter cannot be negative, which was that error that we gave earlier in our smart contract. Now, if we want to, display this error here, what we can do is back in our code editor on this decrement button, we can do on error here. and we can not console log our error, but we can just alert our error here and we can see it for ourselves. So if we come back here and we hit the decrement here, you can see that we get this alert of the error. It was a transaction error, reason being that our counter cannot be negative. So hit OK. Now let's test out our increment button. So we'll hit that. You can see that we get a transaction that appears, and we know that this is now working because we're going to have to pay this gas fee here in order to execute our increment function on our smart contract. So we'll hit confirm here. You can see that it is now loading and we are now executing that function, which should increase this counter to 1. So right there, you can see we have increased the counter to 1. We can also add in our code editor here. Let's go to our increment button. Just like this one, how we added an error and displayed our error, we can now also add something on success. And we can say when it's successful, we'll alert that our counter has been incremented. So we'll come back to our application here. We'll run that one more time. We'll confirm our transaction here. And there you go. You can see we got the alert saying our counter has been incremented. We'll hit OK, and we now have 2 for our counter. Now we created one more function in our smart contract. If we remember, we'll head back to our smart contract right here, we created a reset function. Now this reset function is only callable by our owner with our only owner modifier. And we only want to display a button if the connected wallet is the owner, and we can only execute that function if the wallet is the owner as well. So coming back to our app project here, we're going to need to get the owner and compare it to our connected wallet's address. So we're going to create another variable here. This one is going to be called owner. And again, we're going to use the use contract read hook on our contract. And we're going to read the owner variable. So if we come back to our contract and we take a look at the Explorer again and our read functions, we have the owner function here and it returns us back a wallet address. So we're going to compare this wallet address to the wallet address of the connected wallet to our application. So we'll come back to our code editor here. And at the very bottom here, we're going to check if the address equals the owner. And if it does, we're going to display a Web3 button. But we're also going to check and make sure that we have an address. And if we just have an address, we're going to display some text. And if we don't have an address, we're going to display some text. So if we don't have a wallet connected, we're going to display connect your wallet to interact with the counter. If we have a wallet connected, but they are not the owner of the contract, we're going to just say that you are not the owner of this contract. And if you are the owner of the contract and the wallet is connected, we're going to create a Web3 button here that says reset. And again, this Web3 button is going to take our contract address. And the action here, we are going to call a function from our contract, and that function's name is going to be reset. So if I come back to my application here, you can see we now have a reset button, and that is because the wallet that I am connected with is the deployer of this contract. So if I were to switch this here to another wallet, you can see we have the text saying you are not an owner of this contract. And if we sign out here, you can see we get the text saying connect your wallet to interact with the counter. So we'll connect our wallet here. Again, we're connected with a wallet that is not the owner of the contract, so I can still call functions like this decrement function here. And I can still increment and decrement the functions because, again, we didn't add our only owner modifier to these functions. It is only added to our reset function. And right there, you can see we now have 1 in our counter here. Now, if I head over to my owner wallet. So we'll switch back. You can see we're switched back to the wallet that deployed the contract, and we have the reset button option here. So hit reset. We can confirm that transaction there, and this will reset our counter back to 0. And there you go. You can see our counter is reset back to 0 over here. So again, we created a front end application, which basically created a UI that we could use to, again, interact with our smart contract. Now, if we come back to our contract dashboard here and you go to the Explorer tab, you can actually still interact with your smart contract through this Explorer tab as well, just like you would using something like Etherscan. So if we come back to our write functions here, or if we go back to read and we get our counter is still at 0. So we hit right here and we try to decrement this here and we execute this function. You can see we get the error here saying we cannot execute this function because the counter cannot be negative. So I can do increment here. I can execute the increment function right from the dashboard here. We can hit confirm. And you can see here, we get some information about our transaction from the to, which is this contract that we are executing the function to, the from, which is our wallet address. We have the transaction hash, all of that information right over here. And if we head back to our application, give it a moment, and you can see it updates the counter to 1. Same thing if we head back here and we change our wallet. So let's change to an account that isn't the deployer. So we changed to a different wallet and we tried to run the reset function. You can see that we won't be able to run this and it shows us the error because of our only owner modifier. So again, you can interact with your smart contracts through the dashboard. You don't need to create a front-end application to do so. Or again, you can use thirdweb's SDK and easily start interacting with your smart contracts through your applications. Let me just switch back to my original wallet here. Now on the left-hand navigation here, you can even head to analytics and you can see and read some of the analytics on the smart contract. Now, right over here, you can see that on the smart contract, 2 unique wallets have interacted with it so far for a total of 5 transactions. We don't have any events set up on our smart contracts, but if you did have events, you could see the total number of events that were emitted here, as well as you could head on over to the events tab and it will show the events right over here. But again, we didn't set up any events for our smart contract. So if we head back to our code editor here, we'll just walk through some of the basic hooks that we used in this application and how you can start using these hooks to start interacting with your smart contract. So right over here, again, we use the use address hook to get the wallet address of the connected wallet to our application. You can also use it as a way to see if a wallet is or is not connected to your application. We use the use contract hook, which gets our instance of our contract here so that we can start interacting with it, which allows us to use hooks like use contract read. You can even use a hook called use contract write, which will call any write functions on your contract as well. We use the connect wallet component, which gave us a fully working out of the box connect wallet button that we can then use to connect any type of wallet to our application. And we used something called a Web3 button, which allowed us to call our increment and decrement write functions from our smart contract. And again, all of these components and everything only takes a few lines of code to implement within your application. And with that, you can see how easy it is to start building out your very own dapp using thirdweb. So there you have it. We built our very own dapp from creating our very own smart contract, deploying it with thirdweb, using a thirdweb to deploy that contract, not having to import any of our private keys or anything. You can use thirdweb's dashboard to easily deploy your smart contracts. We also used thirdweb's SDK to create a front-end application and some UI components to start interacting with that smart contract. You learn how to use some of thirdweb's UI components like the connect wallet button to get a fully working connect wallet button to allow users to connect a wallet to your application, along with the Web3 button, which is a UI component that allows you to start interacting and calling functions from your smart contract. And along with thirdweb's SDK and React hooks, you're able to easily build out your very own dapp or Web3 application. So again, I hope you folks enjoyed this video. If you did, don't forget to give this video a thumbs up, hit that subscribe button, and turn on the notification bell so you don't miss out on videos just like this. If you have any questions or need any support, we'll add a link down in the description below where you'll be able to contact our support team. But again, I hope you folks enjoyed this video. I hope you were able to create your very own dapp or Web3 application. And until next time, see ya.